Let us take a look at the example of indeterminate form of the type infinite by infinite. Example, evaluate limit x tends to a log x minus a divided by log a raised to x minus a raised to a. We have limit x tends to a log x minus a divided by log a raised to x minus a raised to a. Given that x tends to a, if we put x equal to a in the numerator and denominator, numerator a minus a 0, log 0 will be infinite. And in the denominator, x equal to a raised to a minus a raised to a is 0, log 0 is infinite. So it is infinite by infinite form. To evaluate this limit, we apply L'Hopital rule. We differentiate the numerator and denominator separately. So we get limit x tends to a. The differentiation of log x, that is 1 upon x. So differentiation of log x minus a, that is 1 upon x minus a. Multiply by differentiation of this internal function. Differentiation of x is 1 and differentiation of a is 0, so multiply by 1. Divide by differentiate denominator. Differentiation of log a raised to x minus a raised to a, that is 1 upon a raised to x minus a raised to a, multiply by differentiation of this term. Differentiation of a raised to x is a raised to x log a, and differentiation of a raised to a will be 0 because it is constant. Now we simplify this term. We get limit x tends to a raised to x minus a raised to a goes to numerator. So a raised to x minus a raised to a, divide by x minus a goes to denominator. So x minus a, multiply by a raised to x log a. Again we put x equal to a here, a raised to a minus a raised to a, that is 0, and put a equal to x equal to a here, a minus a 0, so it is 0. Now it is 0 by 0 form. We apply the same rule, L'Hopital rule. Differentiate numerator and denominator. Limit x tends to a. Differentiation of a raised to x, that is a raised to x log a, and differentiation of a raised to a is 0, divide by, here log a is constant, so log a as it is. Now these two terms containing x, so we apply multiplication rule for differentiation. So first term x minus a as it is. Differentiation of a raised to x, that is a raised to x log a, plus a raised to x as it is, and differentiation of x minus a, that is 1, so multiply by 1. Now again we put x equal to a, the first term numerator a raised to a log a. Here we put a minus a, this term will be 0. Here we put a raised to a, so we get a raised to a log a, divide by, this is log a, this is 0, and this is a raised to a. So we get a raised to a log a. It will be 1. So this is the form infinite by infinite. We evaluate by L'Hopital rule and we get this limit as 1. Let us take one more example of indeterminate form of the type infinite by infinite. Example, evaluate limit x tends to 0 log x square divided by cot x square. We have limit x tends to 0 log x square divided by cot x square. we put x equal to 0 in numerator, log 0 will be infinite. And if we put x equal to 0 in denominator, cos 0 also infinite. So this is infinite by infinite form. To evaluate this limit, we apply L'Hopital rule. Limit x tends to 0. Differentiate numerator and denominator. The differentiation of log x, that is 1 upon x. So differentiation of log x square, that is 1 upon x square. Multiply by differentiation of this internal term x square, that is 2x. Divide by the differentiation of cot x, that is minus cos x square x. So differentiation of cot x square, that is minus cos x square multiply by differentiation of x square, that is 2x. Let us simplify this term. We get limit x tends to 0, this minus 2x cancel, 1 upon cos x, that is sin x. So 1 upon cos x square goes to numerator, this will be sin square x square, and this x square goes to denominator, so divide by x square. Now we know that the limit x tends to 0, sin x by x, that is 1. So we write this term, limit x tends to 0 minus sin x square divided by x square and multiply by sin x square. Sin square can be written as sin x square multiplied by sin x square. We know that limit x tends to 0, sin x by x is 1. So this limit is 1. As x tends to 0, x square will be also 0. So this limit is 1, and as x tends to 0, sin 0, that is 0. So this limit is 1 multiplied by this is 0. So total is 0. So we get this limit as 0. This is the method how to evaluate infinite by infinite form.